All right, here we go, guys. All right, so welcome again to another Operator Framework SIG. This is the October meeting. I had put a call out on the email list if anyone joined. Usually what I'd like to do is have someone external to Red Hat who's working on an operator talk. I couldn't track anyone down to commit to coming this time. Next time, the folks from PingCap said they would come and talk about the TIB or TIDB operator that they've created, depending on how you say that. So there'll be one next week. If someone who comes on the call wants to take a risk and share their operator story, just let us know and we'll do that today. But what I have on the agenda today is to get an operator SDK update from Rob Szumski and a little talk about operator metering from Chance. And I was just looking at the Google group to see what else was bubbling up in topics. After we do the updates, maybe we can talk about some of the stuff that's being talked about on the mailing list. So, Rob, do you want to share your screen or do what you're going to do in terms of an update? And I'll stop sharing now.
Yeah, I don't really have anything to show on the screen, but
that's okay.
So we have a few different efforts underway for getting a more structured version and release process going for the SDK. And some of this discussion has been happening on some of the PRs up in the repo if you've been following that. And what it comes down to is we're going to start rapidly progressing from our current status to more of a 1.0 status once we merge in the controller runtime work. And that work is all about using some of the libraries that the other SIG from API Machinery is curating. And this is some more low-level stuff to communicate with the Kubernetes API and watch multiple CRDs and that type of thing. And so that work has been progressing on a separate PR and is about to be merged here soon. And further complicating that, we're adding a few new types of operators to the operator SDK. So we have the Ansible-based operator SDK getting merged into the main line. That has also been updated to use this new library under the hood. And so what we'd like to do is we'll tag a release of that once we get it merged, get folks to start testing it. That is going to change around some of the mechanics of how your operators work and how they just call the SDK under the hood. But your baseline logic for what you're doing in Go is going to remain the same. And so what we're going to do is have a beta period for that. And then once we iron out all the bugs, which will hopefully not take too long, we'll call that the 1.0, and that'll be our stable API that folks can build against. And once again, since all this is rendered in your Go code, you don't have to update on day one, and your stuff will keep working through the constructs that the Kubernetes API has. So that's a little bit of background on the release process. And I'm curious if anybody has any questions about that, or if they've seen some of the chatter happening on the GitHub issue and wanted to add anything.
Hi, Rob. Just wanted to follow up kind of on what you mentioned. So we already have the controller runtime refactoring changes merged onto the master branch. And we have our latest release version 0.007, I believe. That's the one that's before any of the controller runtime changes. So up until that release, you shouldn't face any breaking changes. Currently, what we're doing is basically adding a migration guide on how to update to the next release, because those will involve breaking changes in how you move from using the SDK APIs to using the controller runtime for your operator. So that's just kind of an add-on.
Thanks. Happy to hear that merge. I must be behind on my GitHub emails.
Yeah.
All right. Having a little bit of lag on my machine. I'm going to mute my video.
While Diane is getting situated with her video, I'm curious, for folks that are using the SDK on the call today, have you been successful updating the versions as they're coming out, or any kind of feedback on that process that we need to take into consideration when we're doing this? No updates? Everybody just cloned it once, and that was it?
Worked fine, or they haven't started using it yet. So hey, one or the other. That's cool. All right, then how about if we move on into Chance's presentation on operator metering, so we can get an update from him on that, and then we'll open it up for other topics. Chance, if you want to share your screen. And I think Chance, you might be muted, so hang on a sec.
So
there you go.
Cool. All right. So I'm Chance. I work at Red Hat and previously CoreOS. I came in with the acquisition, and I've been with CoreOS Red Hat for a little over 3 years. And Rob asked me if I would give a brief overview of what operator metering is, and if possible also a demo. So I have all of that. I thought I'd start by just kind of giving the base idea of what metering is for, what its purpose is, and like what we aim to solve with it, and where you can find out more information. So we are part of the Operator Framework org in GitHub. So if you're familiar with SDK already, or OLM, the Operator Lifecycle Manager, we are one of the projects as part of this org under operator metering. So the project name is Operator Metering, but I want to preface that with the fact that this isn't necessarily only geared towards operator use cases, though that is probably the best way for to get better integration. If you do have an operator, then you can leverage metering in a more Kubernetes native way. So the base idea of metering is that we work closely together with your monitoring stack and potentially other data sources to collect data, store it for long term, and then provide the ability to report on it over time and slice and dice it the way you need. So let's see. Just to give a quick example of kind of what everything actually looks like, we have a guide on how to actually start from scratch, what it looks like to create custom resources for metering involving Prometheus queries, which it talks about here is how to write a Prometheus query, how to feed them into metering, is this portion here, and then continue to iterate until you get data in our database, after which you can query it using SQL right here. The SQL eventually ends up in another custom resource, which users can use to more dynamically iterate or to integrate directly with their operator. And that's what this looks like here. And then at the very end, let me scroll down, you can create a report which is actually going to run the SQL query with the various inputs that you specify and produce the results and make them available for querying, at which point you have an API, which you'll be able to query, and then get the results as a CSV. So what I'll do is I'll actually go through this in more detail, but that's just the rough rundown, is that it starts with a Prometheus query. You start ingesting the data through the reporting operator. Reporting operator then has the ability to query it using some SQL that either you write or we write, and then you get that query to run by creating a report or a scheduled report, which actually says, what do you want to report on? So in the background, I already have an installation of metering running. By default, it runs a set of pods for storing our data, for querying it, and then also for the part that runs collection and the actual queries themselves. In particular, the primary component here is the reporting operator. It's the one that does the data collection for Prometheus, and it's also what queries the database, which is Presto, for all of the real work on the underlying data. We use HDFS for storage, but that is something you can change. You can actually also use S3 natively as basically a file system, is the way you can think of it. Or you can also use a local disk that is mountable on all the pods. So like NFS, BlusterFS, DefFS, anything that's mountable by many pods could also be used as a storage engine for this instead of HDFS. As I mentioned before, we have a number of custom resources. Let me actually list this.
Can you make your font a tiny bit bigger, Chance? It's really tiny. Thank you.
Big resolution makes it a little hard to tell where it's right. Let me see if that gets the full list. Custom resource definitions. All right, so we have a number of custom resource definitions. So the top one here is the metering resource. It's kind of the resource that tells you to install everything. Our metering operator installs the pods listed above, Presto, Hive, reporting operator. It does all that through the metering resource, which is basically the config resource for installation. We have some Presto tables, which people don't usually interact with, but they're kind of for storing some of our state. And then the rest are all things that I would expect the end user to deal with. So there's a report data source, which is basically incoming data or data that already exists, and I'll show you that. There are report generation queries, which are the SQL queries that we saw before. There's the report Prometheus query, which is a Prometheus QL expression for collecting data out of Prometheus. And then there's reports and scheduled reports, which are the parts that actually act upon that data. The storage locations are a way for configuring whether or not you want your data to be stored in HDFS, S3, or a local file system, for example. So starting from the bottom up, I'll start with data collection portion. We have these report Prometheus queries, which are really simple. They are an actual Prometheus expression, PromQL queries. So let me make this a little easier to read. So I'm just pulling out the, really? That's all. 1 second here. Why is that? Oh, there we go. So we have an actual Prometheus QL expression right here. This is not the easiest to read, so I will make this font slightly smaller. See if I can get a line break in here. But this is a large Prometheus query expression that gets the container's memory usage. And then does it by grouping it by pod level, so you get pod usage information instead of just container level. And then we do a bunch of joining basically at the end to correlate it with other Kubernetes data so that we have like the pod name, the node name, and the namespace. And so this query is just run by the configuration of the data source. Which actually is what maps eventually down to a real table that we can query. So the report data source has a Prometheus query name, which is the name of the report Prometheus query we looked at before, pod usage memory bytes, and that configures the operator to actually go and collect this periodically. This section normally can have some extra options for like how often to pull and like chunk sizing for like how much data to grab at once. But by default, it would just use some global defaults. And then we have a status, just like every CR, which stores other information about this resource. In this case, the table name field is set, indicating there's a database table created for this and that we're collecting the data. So now that we have a data source, we can actually query it from our database using a report generation query. So there can be many report generation queries that act on the data sources. That's kind of the idea, is that the data source is the underlying raw data, and then you can have 1, 0, or more queries that actually utilize that underlying data. That way, you don't actually have to collect the data more than once for processing it in different ways, which is obviously useful. So let me actually just open this in the edit view. So a report generation query, just like everything else, has a name. All this other stuff is auto-generated because it likes to fill in the metadata. We have a set of columns, which is basically what we expect this query to output in terms of like a database schema. If you're familiar with like a SQL table, this is roughly what that maps to, is the columns in that table, and then some extra information for how to display it. Reports can take in custom inputs, so you can like override their default behaviors and program them dynamically a little bit. Right now, most of our reports only allow overriding the start and end dates. And then there's the actual SQL query, which is just ANSI SQL that has some Go templates in it that get pre-processed before the query is run to allow us to do things a little more dynamically. So this SQL query is doing an aggregation on the namespace pod and node to get us a pod level usage query that indicates how much memory a pod has been using over time. And so we have a bunch of different ones, and I want to show you the one I'm going to run, which is the namespace memory usage query. And it's very similar. The main difference is it's got less columns, and let me show you the query. Spec query. The SQL query is the same, except instead of being grouped by the pod and the node and the namespace, it's just grouping by the namespace, which in the end will give us a sum total of memory usage in the namespace over time. So to use these, we have a concept of reports, schedule reports, and I've actually already created a schedule report for us. So the schedule report I want to show is this one. So we have an hourly report, 2 reports actually, one for memory usage and one for CPU usage. And what these do is they run the SQL query specified by the generation query field, and they run according to a particular schedule. We can do hourly, daily, monthly, whatever you want really. We also support cron for the more flexible use cases as well. And so it will report from data starting at the reporting start time until the reporting end. We don't have a reporting end, so it's going to report forever, which is what I want for this purpose. And it will retroactively go back and fill in the data that's missing from the start, assuming we have the data collected from Prometheus already. And so, as I showed before, this has been running for about 10 hours since last night, so that we actually have some more than just a few rows of data. Before I show you that though, we can see the status to indicate like where it's at in the report. If we're backlogged or anything, you can check where the last period it ran for is. And then because I'm on OpenShift, but this works with regular Kubernetes as well, I'm using routes. You can use load balancer services or node ports as well. I have a route that is configured to expose my endpoint at a particular domain name here. So I actually already have a command set up to query it. Yes, you can query it, but it's not really anything I'm too worried about. This is the CI cluster. I set it up with auth using the OpenShift auth proxy, and I'm querying the route that I just showed before. And then this is the endpoint, the API v1 schedule reports get, and then a bit hard to see, but I'm querying for a particular report, which is the namespace CPU usage hourly, and I'm getting it in tabulated format. So when I query that, we basically get the results as tab delimited format for each column, period start is the start time for the given scheduled interval. So it's an hourly report. So each period start to period end is 1 hour. The namespace is the namespace that we're calculating on. Data start and data end are the min and max of the values in that time range. And then the pod CPU usage core seconds is the CPU at every instance in time multiplied by the resolution of that data, all added together to get us an actual CPU core usage seconds. And then we do this for every hour. So we have 13 to 14, 14 to 15, and everything up down to basically the last hour, 15 to 16 UTC. We have that as well with memory. And you can see the same value, except it's in bytes, and it's a different set of values for these pods usage information. So this is actually all coming from Node Exporter at the end of the day, and then Prometheus collects Node Exporter data, and we do some extra processing with the SQL and the Prometheus query to get it into this format. But that means basically that if we ever needed to change how it works, all we have to really do is modify one of these resources, like the namespace memory usage request. I can just edit it and modify it to my needs. So that's the rough idea of like how you interact and use Meter. But there are other things you can do. We're currently working on another concept, which is, let's see. Yeah. So this is a regular report, but the concept is that you can have custom inputs where you could imagine having a query that maybe is specific to a particular namespace, and you could add field inputs to it that customize the behavior so that it filters everything that's not the namespace that you want. Maybe your CI test namespace, and you only want to report on that namespace. So this is something that we just added and is currently being worked on, so I don't have a great demo of it because none of our queries utilize these custom inputs very heavily yet. But that's something that we just released. And then we're also working on, with this feature, a concept of rollup, which allows you to calculate really granular reports that have like maybe say like the hourly interval that I was showing. But then this could be rolled up into a daily report, which basically aggregates the hourly results, and then you could continue to aggregate at higher levels to have accurate snapshots either at one interval or at a higher interval, or sorry, resolution, without having to actually compute the whole series of data across the lower granularity. Yeah, so that's the rough idea. I don't really have a whole lot more. Given that all of this is just custom resources, the real power here is that you can program it using Kubernetes just the same way you could program anything else in Kubernetes. If you have an operator that wants to interact with this system, it can do so using typical Kubernetes technologies like operators or kubectl. So you don't really have to worry so much about like how does my component integrate. It's just the same way you would interact with any Kubernetes system. So long term, the SDK will likely have bindings to create various report queries, Prometheus queries, and will integrate directly with metering to be able to expose your metrics, make them collected by metering, and then potentially even report on them automatically without your operator having to do any really extra steps, potentially, except for define what the query should be. So that's where I'd like to see it go, but I'm open to any ideas as well. Anything you want to add to this, Rob? Or something I should cover?
No, I think you covered it. I do have a random few slides on some diagrams if that's useful for folks, but might as well just go ahead and share those really quick.
If there's any questions, just pop them in chat or unmute yourselves and ask them. While he's doing that, you got that shared? Okay, go. There you go.
So here's kind of how it all comes together. If few examples of how you can use this in a real environment. So Chance is showing us all the reports and all the stuff under the hood, but at the end of the day, say if you want to do show back for a number of different teams, each team has 3 different projects, and they have a certain budget. You can run the reports that Chance was just talking about and get the usage. And on Amazon, we can actually correlate to a dollar amount, which is really cool using the Amazon billing API. And so you can get those into Excel and just sort them and group them by the different namespaces and total things up just manually. Or because these are all just using CSVs, you can actually import these into your business intelligence tool of choice, whatever you want to do, and make dashboards out of these and have a more automated flow. You can also start doing a number of kind of like augmented math, if you want to call it that. So if I've got like 2 bare metal clusters, for example, and I know how much that I'm leasing the hardware for a certain amount, maybe I've got a block of bandwidth that whether I use it or not still costs me money. And so if you wanted to combine all of that infrastructure cost together, of your shared like enterprise NAS device, for example, you can take some of the usage from these reports and combine it with that fixed cost and multiply that stuff together, and then show that back to your teams, whether in another Excel document or in that BI tool. Hook it up to any of the other cost reporting that you might be doing, email reports, that type of thing. And my favorite use case for this of all is you can shame teams that are underutilizing what they've reserved. So if you're asking for more than 2x what you're using on the cluster itself, you can start shaming those teams, calculate the ratio of what they're using and what they're not, list them out, say exactly which apps need to be, yanked down to size, or even just go ahead and do that for them. You could have automation that's running, that's automatically adjusting people's resource limits and that type of thing. So it's pretty exciting. This is, all using cluster metrics that we have today, and that is one whole use case for this. But you can also, export custom metrics from your operators, and so that is kind of the other use case of this. So the cluster monitoring and gaining insights from that is great, but if you've got a database operator and it's emitting metrics for the different things that it's tracking internally, the number of rebalance operations or things like that that are critical to how it works, or the number of tables that people have or the size of those tables, you can start exporting those and using this same framework to do that, which is pretty exciting. So that's kind of a reverse order. That's the high level. Chance gave you the low level. So let us know if you have any questions, and we're excited to be testing this out with folks on their Kubernetes clusters.
All right. Well, I think that it probably covers off metering. I'm not seeing any questions. And Daniel Feinberg from Pantheon's been asking in the chat a lot of questions and updates around the controller, which I think he joined late and we missed him out. So I'm going to unmute you, Daniel, so you can introduce yourself and what you've been working on, and we can kick off a conversation. So Daniel, you should be unmuted now.
Am I unmuted?
Yes, you are. We can hear you. So just introduce yourself and let's.
So I'm Daniel Feinberg. I'm a senior engineer SRE at Pantheon. We are a Drupal and WordPress hosting platform. We also offer developer tools to agencies. And we host about, 150,000 sites. It varies quite a bit depending on the day as customers join. So we host a large-scale Cassandra infrastructure in 2 different ways. So we use Cassandra in 2 different major pieces of our platform. And so we're in the process of building a Cassandra operator. I know that there's a few of those being built. And we have been writing the master branch until yesterday, or the day before that, I guess, for the operator SDK with the Cassandra operator. So we had to pin it until we get a chance to do the upgrade, which I'm hoping to do this weekend, to the runtime, because there's features there that I'm really excited about that we've all been kind of talking about. So our other operator is a machine operator. That is also right now being built. It's not running in production. We have our Cassandra operator operating production Cassandra clusters in a very simple way. Our larger monolithic database will be migrated hopefully by the end of the month, probably in the first 2 weeks of next month is more realistic, onto the operator's management plane. So our machine operator is actually, we wrangle and maintain systemd containers in large quantities. All of our customer code runs in systemd containers. No Docker, no images, systemd, namespaces, C groups, all the base stuff. We've been around about 7 years, and when they built this out, Docker wasn't there yet. And so the large monolith in our system is an orchestration plane, and our goal is to slowly piece that out into operators in Kubernetes wrangling our systemd containers. Our first step there is putting kubelets on all of our servers that run the systemd containers and bringing in a provisioning tool that is being built as an operator. It will deploy daemon sets to manage services on each server that work and integrate for customer load on our servers with those systemd containers. So the machine operator is super interesting and unfortunately won't be open source. But what the big deal for us is that we're moving into a way where Kubernetes will be our central database for infrastructure. We'll be using it, like right now, the machine builder operator doesn't really do much beside daemon sets and allows us and our monolith to provision all the systemd containers still. And so kind of utilizing etcd and Kubernetes in its multi-region way, we use GKE at Google, or multi-zonal way, to store all of our operational information, whether or not it affects Kubernetes, and using its event-driven system and operators to operate on Kubernetes resources, but also external things that Kubernetes isn't managing. So kind of a hybrid operator there. The Cassandra operator, like I said, will be open sourced. I have one regression and a little bit of finalizer work and the upgrade to do. So, yeah.
Awesome. So is
Very
the
cool.
Cassandra operator that you're building, is it really specific, or is it something that's useful to the rest of the community at large? Is it specific to what you're doing at Pantheon?
No, well, because we have two different kinds of use cases for Cassandra. One is a multi-region, eventually consistent setup, and the other is a three-way data replication for a metadata for a distributed file system, which is publicized. We maintain a distributed file system for our customers, and the metadata is stored in Cassandra, and the files are stored in GCS on Google. And so the two different use cases have had us broaden out the scope and spec of the management of the Cassandra cluster. There's definitely, like, we maintain two different versions. I'm not going to say there's one version that's no longer supported that we're trying to get off of, and another version is the 3.x line of Cassandra. So ours will be specific to the containers. Like, you'll have to use our images with our operator because we have some logic inside of the entry point files and the Docker images that do calculations that can't be done at the level of the operator to set up configurations and things. So there's definitely design decisions that we've made that are based on our feature set, but I believe that by open sourcing it, we can set up things like, oh, we do repairs differently. Let's code an adapter and an option in the CRD to be able to swap in and out different repair techniques, right? And I'm hoping that open sourcing the project will allow us to broaden those features and use cases.
Very cool.
Yeah, so thanks for sharing that update with us, and I look forward to seeing that Cassandra one out there in the wild. Let us know when it's ready for us to take a look at it.
I'm hoping early November. As soon as we get our monolith migrated and see that it's stable, then I'm hoping to put that out. Sean just asked about the controller runtime. I missed the beginning, and part of my project this weekend is to hopefully migrate to the controller runtime version of the Operator SDK. So I'm wondering if maybe someone can speak to how hard that's going to be and how much change that's going to be across the code base for a user.
Right. So I can kind of jump into that, Daniel. So we don't have the migration guide out yet. We're planning to have it out, I guess, this coming week, along with the release that tags all of the changes on the master. But kind of at a high level, there is a fair amount of change involved in just the interfaces that have changed, because we've moved over from using the SDK APIs like SDK.watch, SDK is the handler that you have in the SDK. You move those over to using the controller runtimes controller package, essentially. Most of your reconciliation code would probably stay as is. It's just that you would need to update the project layout just a bit. So if you look at the master branch today, and if you try to create like a sample non-cache operator as an example, you'll be able to see just what the new project layout looks like. So there is a fair amount of change involved in actually taking your reconcile code and just moving it over to a controller package, and then just kind of changing the interface to the reconcile code. So previously, where you would get events sent to your handler, now you basically get like an object key that you use to look up the object in the cache, for instance. So there's some changes around the edges, but I think by and large, the bulk of your like operator code should stay the same. And if you're using multiple custom resources within your SDK-based project today, that should also be easily translatable into the new controller runtime layout with multiple controllers, or you could kind of define how you want to have relationships between those custom resources. This is kind of what we're going over in the migration guide, but you might be able to get an idea if you just kind of go with the user guide that we have on the master right now. We should be updating the samples operators as well to use the new controller runtime. So that should also give you kind of an idea of how the handler maps to the controller's reconciler. But there shouldn't be like anything that you wouldn't be able to actually move over. So hope that kind of answers your question.
Yeah, it does. Thank you. Also, can I follow up about unit testability of the new setup?
Right. So with the controller runtime, you basically end up getting a separate client object within your reconciler, and that client object, there's actually, you can actually like fake that client and set it up with your own custom resources or objects beforehand. So the controller runtime has a fake client package for that. So that should hopefully make unit testing a lot more easier when you're trying to test out the reconciler in your controller. And so we don't have an example around that, but maybe that's something we can add up as a separate doc on how to use that fake client package.
Just as another data point, we moved the Ansible operator over to the controller runtime a while back, and as Steve was saying, most of our core logic didn't have to change. We just had to change the interfaces it was calling. So that was really nice. And then the rest of it is like moving files to the new locations. So as far as amount of work, it should be like, it should just be about moving files into the right locations or renaming them. But as far as like the core logic, it shouldn't change that much. Your main file will change some because you need to set up a manager and do some of that other stuff. But you can kind of just take the core, like the controller runtimes like example, just like take that and it'll mostly work for you. So just a heads up as you're starting to go through things.
All right, then. I was asking in the chat if anyone else had any updates. And Chaorun was going to ask for a slot today about GCP Spark Operator. Oh, I apologize for that, Chaorun. That got lost in the email threads. We have 15 minutes if you'd like to take it. I'd quite like to hear it. So why don't you share your screen and take it away? And if we run a little bit.
Sure. I can go a little bit quicker, but just give me a second.
Apologies.
No worries.
I knew there was somebody else, but I couldn't remember who it was.
Yeah, so I can go quick on some stuff and sharing screens. Oh, I need to install the Philippines extension. Just give me a moment.
It's a quick install.
Yeah. So while he's doing that, I just wanted to make an announcement. We did get a room at KubeCon North America to host a Kubernetes operator framework hands-on workshop. It is on the December 14th, Friday morning, the 14th, in Seattle. It's not actually at the convention center. It's going to be at the Seattle Sheraton. So if you are interested in joining that, I will send the information out on the mailing list right after this call. So Chaorun, take it away.
Okay. Yeah, sure. Today I can talk a little bit about the Google Cloud Platform Spark Operator. I think 2 weeks ago I attended a SIG meeting where Jerry presented his Spark Operator. But this one is from Google. I think it has more momentum and more contributors and users. So let's look at what it's about. So I have a few things I want to talk about for today. So to get started, I'll just talk briefly about what the operator pattern is, but I think most people are already familiar with it. But this GCP Spark Operator is basically an implementation of this pattern. And then I'll talk about the architecture of this Spark Operator, how to install it, and what some of its basic features are. And then I'll talk about a CLI tool that's provided in this operator project called the Spark CTL. It makes some of the workflow with managing Spark jobs easier, as we'll see. Then comes a feature called Mutating Admission Webhook. This is a feature that the Spark Operator leverages to provide lots of flexibility in customizing your Spark driver and executor pods. I think this is one of the most useful features in this project. As the last thing, I'll talk about exporting and looking at Prometheus Metrics with this Spark Operator. I'll conclude with some future things that you can contribute to this project. Okay, the operator pattern. This is a way of packaging operational knowledge of a complex or in many cases stateful application and make it native to Kubernetes. Native means that you can interact with this custom resource or your application using standard Kubernetes tooling, for example, kubectl. And just as you would interact, how you would interact with traditional Kubernetes resources like stateful sets or deployment or pods. And so the purpose is to abstract away those details and provide a smoother user experience. What it really is it's an application specific controller that extends the Kubernetes API that makes managing this complex application makes management, creation, and configuration easier. The way it does it is it's an event loop that's constantly running. The operator component keeps observing for events, listening for creation of a new custom resource, for example, and then once something happens, the operator evaluates the current status, what it should do, and then it acts on the insights that what it thinks it should do, and this event loop keeps going. Then let's quickly get into the gist of the talk, the specifics of the GCP Spark Operator. It was created by this guy called Yinan Li at Google, and it's now open source. The link is provided on the slide. The approach that it takes to managing Spark jobs is that it creates two custom resource definitions, or CRDs, one called Spark application, another called scheduled Spark application. So those CRDs represent abstractions of a Spark job. And they are what make Spark jobs native citizens in Kubernetes. You can, as we'll see in a minute, you can interact with the Spark jobs, manage them, and monitor them using standard tools. The goal is to streamline the creation, management, and monitoring of Spark jobs. Let's take a look at the architecture diagram of this project. So the way it works is that you would document your Spark job application, Spark job specification in a YAML file. So here in the example is sparkpy.yaml. We'll see an example of this, the content, what the contents look like in a minute. But once you have the Spark job spec documented in the YAML, you would use kubectl or sparkctl that we'll talk about. Use these CLI tools to submit your YAML to the API server. And once the API server receives your request to, for example, create a new CRD Spark application or scheduled Spark application, there's a component called controllers in the Spark operator that would get this request and assemble all of those configurations and pass them to another component called submission runner. So what the submission runner does is basically there's a translation going on, because in the YAML you have all those configurations that you want your Spark job to have, and then the submission runner is translating those configurations into a Spark submit command, and it runs that Spark submit command by talking to the API server. And then the API server would in turn create the driver pod, which then would launch executor pods depending on your configurations. There's also a component called a pod monitor that keeps monitoring the pod events. There are also optional components, mutating admission webhook, and that we'll see in a little bit. The basic features are because it uses a YAML to document the spec of a job. So the YAML is declarative in nature. It's easy to do things like version control. And because under the hood, what it really does is it runs a Spark submit command. So everything that Spark submit takes of those configuration options, the Spark operator also supports. You only need to figure out what you need to put in the YAML. The translation, you just need to know that. There's a good documentation. It's easy to figure out. It also supports a cron-like scheduled Spark jobs. So that's what the CRD scheduled Spark application is for. And the interesting feature is mutating admission webhook. The operator uses that to enable pod customization. You can mount config maps or volumes in your driver and executor pods. We'll see that in a few slides. You can also use the Spark operator to enable automatic job resubmission if you would like to change the specs of an existing Spark job, or to restart it if upon failure, if that's what you want. at the end, it also supports exporting Prometheus Metrics. This is an incomplete list of features, but I think these are what the main things are. Let's talk about prerequisites. It requires Kubernetes 1.8 and above because it relies on garbage collection of customer resources that's only available starting 1.8. And if you would like to use mutating animation webhook, then Kubernetes 1.9 and above is required because this feature is only becomes the beta feature starting 1.9. And exactly what distribution of Kubernetes you install the operator in doesn't really matter. Personally, I've used it on GKE and OpenShift. Both worked fine. How to install it? It's easy to install because there's an incubator chart on the central Helm charts repo. You basically add the repo, Helm repo, and install it. Just what you would do for any other standard chart. And there are other options to customize it. For example, you would like to install it in a different namespace, or there are some components that you would like to enable or disable. But you can look at the link. There's a concise documentation that you can look at. I won't go into details here. Now let's take a look at a sample YAML, what it looks like. So here, so basically you would like, you name your Spark job like SparkPy, and you would like to run it in default namespace. That's where you specify your namespace, and you provide your image, your main class, application file, so all standard things. Then you can configure a driver pod to with some memory resource requirements, what service account you would like to use, and how many executor instances you would like to launch, and resource requirements for executor. So this is a very simple YAML, and you can have all sorts of other configurations too, as long as the Spark Summit supports it, and you figure out the corresponding spec in the YAML. But this is what it looks like. The basic operations, very easy because now the CRDs are there. Then you can just create a Spark job, for example, just as you would create a pod. kubectl apply the YAML, and to list all the jobs, k get Spark applications, the name of the CRD. To get other details, for example, events, you can do a describe, delete, very standard things. Let's now look at the custom CLI tool provided in this project called SparkCTL. So here I said it complements kubectl to make some operations easier, but I would say that it can fully replace kubectl when working with Spark application or scheduled Spark application CRDs, because everything that kubectl can do, SparkCTL can do, and it makes things easier. For example, listing all Spark jobs, you can do SparkCTL list, but with kubectl, you would have to do kubectl get Spark applications, things like that. So it's longer, but this here is shorter. To get the status of a Spark job, SparkCTL status SparkPy, again with the kubectl, the command is a little longer. To get the events, again it's shorter, but with kubectl, you have to do a describe, and Spark application, things like that is longer. And getting Spark job logs is again a one-liner, but with kubectl, you need to first find the pod you would like to, the pod corresponding to your Spark job, and then get the logs from that pod. So it's two commands, but here it's one command. Just some syntactic sugar that makes your job a little easier. Besides that, there are a few other features. SparkCTL also supports port forwarding to view the web UI. Again, this is something that kubectl can do, because with kubectl, you can again just figure out the pod first and then do a port forwarding on that pod. But here you don't need to find the pod. You just know the Spark job name. Here is a SparkPy, so a little easier. It also supports staging local dependencies to S3 and GCS. For your dependencies that you specified in your SparkPy YAML, you can specify your GCS bucket or S3 bucket to upload them to a remote place. But you need to configure your authentication and stuff upfront. The details are in the documentation, which I won't talk about here. Let's see how much time I have left. Okay, so now let's go to the mutating animation webhook. So this feature is it's a feature about of Kubernetes itself rather than the operator, but the Spark operator leverages this feature to enable flexible customization of pods. What this feature is a so-called animation controller that intercepts requests to the API server and modifies an object before the object is persisted. As I mentioned, it's a beta feature in 1.9 and above. And the Spark operator uses this feature to achieve mostly 3 use cases. The first use case is mounting config maps in driver and executor pods. The second feature is mounting volumes. The third feature is setting pod affinity and anti-affinity, things like what nodes you would like to run on or which nodes you would like to avoid. Let's look at a few sample use cases. So when would you like to mount config maps in your Spark job pods? So here's an example. So it's very common to have some custom configurations for a job in Spark defaults.conf, sparkim.sh, or log4j properties. So these files are very common, and in order to have these custom configurations in your Spark jobs, you need to have them available in the pods. And the way you do it in the if you are to use a Spark operator is that you first mount these. So you first mount these files as config maps, and then in your YAML file you simply refer to that to the config maps that you've created. And then when the Spark CRD the Spark job is created, those config maps that you've pre-mounted would be automatically mounted inside the pods, inside the driver and executor pods, and then your Spark job would be automatically configured as desired. Another use case is supporting Hadoop configurations to access HDFS. For example, you would need core site XML and HDFS site XML. These files, again, you can mount as config maps and refer to the config maps in the YAML, which would then bring in the config maps and mount them in the pods once your job starts. So this way you achieve connections with the HDFS. Another use case with the mutating animation webhook is mounting volumes. So here a use case that I've encountered myself is in the use of Spark history server. In this case, both driver and executor pods of a Spark job need to log events to the same volume, which is also the volume used by the history server pod itself for use in like displaying on the UI, for example. So here, for example, I have a PVC volume, and then in order to have the driver and executor pods log to that volume, you need to have this driver.volume mounts. You specify the name of the volume that's available here, and then the path that you would like to mount the volume at. Yeah, this way the volume is available at this /mount directory, and then you can log events there, which are configured here. Yeah, so these are some use cases for the mutating animation webhook. I think it's a pretty useful feature, but it's an optional component. You can disable it if you don't want it, to use it. Yeah, last but not least, let's talk about Prometheus Metrics. The Spark operator configures a Prometheus JMX exporter to run as a Java agent in the operator pod itself, but it also supports emitting metrics, Prometheus metrics, in the driver and executor metrics themselves, in the driver and executors themselves. So the two sets of metrics are in an application-specific metric. For example, Spark driver app status job duration. So this is a metric that's specific for that job, coming from a driver or executor pod. There's also a set of metrics that are higher level, for example, Spark app running count. So these are metrics that are specifically provided by the operator pod itself. So these are application metrics. application level metrics. But know that to expose driver and executor metrics, so the first set, your Spark application image that you specify in your YAML that needs to contain the Prometheus JMX exporter Java agent jar. Otherwise, the metrics won't be exported. But once you have that jar available in your image, it's easily configurable to have those metrics exported. Yeah, here's a sample YAML file that configures the driver and executor metrics to be exported. So these are for the first set of metrics that I showed in the previous slide. The operator pod itself already configures itself to export application level metrics. This slide is just the general thing about how you would look at those metrics. You can look at them in the Prometheus UI, or for example, you would like to verify the list of metrics exported by the Spark Operator pod itself. Then you can find the pod and then do a port forwarding on that. The default port is 10.254, and once you have that port forwarded, you can go to the metrics endpoint to see the list of the metrics, the application level metrics that will be shown here. The same is true for the driver and executor metrics. You can also look at them there. The future work is that the current status of the project is that it's fully compatible with the Spark 2.3 and 2.4. It's been tested with the 2.4 release candidate versions, and it's currently alpha, but it will be upgraded to beta once 2.4 is officially released. So here at Lightbend, we are actively evaluating and contributing to this project. So our past contributions included the Helm chart and the integration with the Prometheus and Spark History Server. The project is still in its early stage, and it requires lots of testing to make it mature. So more integration tests are a thing that needs to be added, and we are also working on that. Also, Kerberos support that's currently lacking. Also, Spark CPL doesn't have very good support for scheduled Spark application. That's also something to be added. Just a few words about the team I'm in. I work at the Lightbend. The team I work in is called Fast Data Platform. So we are the product is a curated, fully supported platform that helps developers design, build, and run data pipelines. And our emphasis is on streaming data. So data that moves in real time, and Kafka is obviously a very important component. But our entire architecture is built on top of Kubernetes. We used to be based on Mesos, DCOS, but now we are re-pivoting on top of Kubernetes. And Spark Operator is our at least for now, our project of choice to managing Spark jobs on top of Kubernetes. Our release is going to our upcoming release is going to use OpenShift as our Kubernetes distribution, and we've been testing on OpenShift with the Spark Operator and all of the Spark related components, History Server, for example. And currently it's looking good. So I think this is a promising project and has a lot of activity. So I encourage you guys to try it out and maybe consider contributing. I think I went a little bit too fast because of a short of time. But if you have questions, you can shoot me an email or just talk to me.
Perfect. Chaorun, thank you very much for taking the time, and I'm looking forward at some point soon to getting a demo of the Lightbend platform. So hopefully we can schedule some time maybe for a deeper dive briefing on that.
Yeah, sure.
Share a link to your site. That would be great. And I will post all that up on the mailing list a little bit later today. And so thank you, everybody. I don't see any questions in the chat at the moment, but I will post all of this. And Sharon, you can reach out to him on the mailing list as well. So thanks again, and we'll be meeting again on the third Friday of next month. But you can find us all always on the Google group mailing list. So That was really great, Chaorun. Thank you very much for all the work you've been doing on that. And much appreciated.